Good morning, everyone. Thank you for coming to this presentation. And I'm Dong Junnan. On behalf of the first authors of this paper, I would like to present our work on creating an online question answering system based on knowledge graph to answer college-related questions. And before talking about the details, I would like to briefly provide a brief introduction on the background and the task setting, and then the motivation why we're pursuing this topic and the target, and then the overview of our system on how we alleviate and solve the problem. And at last, I would like to show you a brief demo of our system by asking two typical questions. So first, as introduced in the last talk, knowledge graphs are an efficient data structure that could effectively represent the real-world assertions in the form of triple with the head entity, a tail entity, and their relation. And benefited from the abundant real-world assertions and the common sense buried in the knowledge graph, they are widely adopted to answer questions and improve the performance of question answering systems. A simple example here is that who painted Mona Lisa? And by using this knowledge graph, we can straightforwardly get the answer. Da Vinci painted Mona Lisa and derive the answer of Da Vinci. And here comes to the motivation why we're pursuing this target for creating an online question answering system for college-related questions. I believe the situation is everywhere in different universities. And my name is Hansen. So during these years, I've been receiving tons of questions like from my teammates and lab mates like, hey, Hansen, do you know where can I print my posters? Do you know how can I contact professors or which building? Do you know where is a building or a seminar room? So I've been receiving a lot of questions like that. So we realized that it is very important for us to create an online question answering system for college-related questions and provide pedagogical advices to students. So this is our motivation. While almost all the existing KGQA systems are currently built upon general open source or common sense knowledge graphs, which means they have no inferential capabilities to answer such kind of questions. And another limitation is that currently almost all the KGQA systems can be categorized into two parts. First, the traditional rule-based methods. They're considered very efficient to answer simple questions by creating the predefined logics. And another type is the embedding-based method. They are actually black boxes to use neural networks to improve the accuracy and consider rather accurate than the traditional rule-based method. So to alleviate the problems in this paper, we explored to propose an integrated framework with rule-based component, embedding-based component, and additional content-based component to solve the problem. So as our target, we mainly want to answer questions from these two aspects. First, for the college-related questions in the Hong Kong Polytechnic University, abbreviated as PolyU, we'd like to, these are some typical types of the questions from tons of questions that I have received. So we expect the system to answer faculty information, staff information, department information, and those questions about facilities, the master program, or the location of different buildings and the course information. And for CS domain, actually, to be honest, this work is done before ChatGPT was released. So a pure KG based question answering system is much less powerful than a GPT series of models. So, but Poly enabled the model to be inferential capable of answering a college-related student questions are still our main contribution. Yeah, and these are some typical questions specifically choose from what I've received. Like, how could I contact professors? Where can I find the academic registry? And how much I need to pay for the tuition fee? Yeah, such like that. And this is the overview of our system, including, so after manually constructing the knowledge graph by using Python crawler from our websites and matching the Wikipedia, we input in a natural language question. So first, our system will go through the rule-based component and to find the best matching roles to answer the question very quickly. But if our system find that there's no predefined rules can answer this particular question, and then the system will go into the KGQA component to solve the problem by using a KG embedding-based method. And after scoring all the triples and candidates, if we find the probabilities of all the candidates are below or lower than the threshold that we define as the hyperparameter, then the content-based QA component will be activated to answer the question. So let's first see how rule-based component works. And after receiving a natural language question, we in parallel detect the head entity inside the question and find the best matching rules that we predefined. And so it will never be a rocket science if we have fixed the two elements of the triple and then use it to answer the question with knowledge graph very quickly. So here goes to the KGQA component by using the knowledge graph embedding method. And also in parallel, we have two major algorithms to first detect the head entities and then a representation learning model for learning the vectors for entities and the predicates, which is the relation. And to improve the entity matching algorithm, because we have a lot of disambiguation problem in the real world for user input in natural language questions. So we have adopted an existing string matching algorithm to match the exact entity name in the knowledge graph. And after obtaining the vectors of the predicates and entities, we concatenate them as the triple embedding. And then by adopting the mechanism of trans-E, we calculate the scores for all the candidate triples retrieved from the head entity detection model. And then we prioritize the top ranked triple as the answer. So this is the component how we obtain the entity and relation representation. First, we value the sequence of the inputted sentence for either questions or entity name, and then go through a by WSDM to have the forward and backward hidden state vectors and combine them as the final vector and use this to calculate a tension weight and combine the initial vector of the input and the concatenated hidden state vector to go through a fully connected layer and finally get a output embedding for the final predication and the head entity vector representation. So at last will be the content-based component if our system cannot answer this question by using predefined rule-based component and the KG embedding-based method. So after receiving the natural language question, we first do a document retrieval from all the learning materials and course context. And after that, it'll be a content reader by using the pre-trained language model to provide the answer. So in particular, we use TF-IDF to retrieve the documents and a pre-trained BERT series models like Roberta to provide the answer. Then, before conducting the experiments, here are some data statistics. And we've manually constructed over 15,000 triples for college-related and CS domain-related questions. And we've defined 38 rules and prepared 41 documents from learning materials and the course contexts. And also we've asked 14 master students to manually create 730 questions. And after checking, among them, there are only 638 valid questions. And after scoring and evaluating our system, the system obtained an 83.6 accuracy for both poly and cis domain. And after that, I would like to show you a brief demo for answering two simple questions. First, it will be, I'm not sure whether you can see it clearly. It will be asking for the compulsory courses for the MSc program majoring in information technology. And through this, the system will very quickly go through the rule-based component to answer and find the best matching rules. And for the second question, what is the phone number of the professor? And this time, the system took a little bit longer to answer this question because the inputted natural language question is ambiguous because the professor name in the system is recorded as doctor professor name, but in the question, we won't have the doctor name. So the system took a bit longer to solve the disambiguation problem. Sorry. Then, as concluded, we designed an online QA system for the student advising and pedagogical assistance with an integrated framework, with both rule-based and occasion embedding-based components to solve the to balance both accuracy and efficiency problem, and add an additional content-based components to ensure the accuracy for unseen or predefined problems. And for the future work, we're still investigating to apply more cutting-edge multi-hop KG reasoning method to answer complex questions. And also, as a chatbot, the continual learning ability for this conversational chatbot will still be one of the main focus of our paper.